Do you know what the Coriolis effect is? It is a common perception that the rotation of the Earth causes the water to spin clockwise down your bathtub drain if you live in the southern hemisphere, and anti-clockwise if you are at the northern hemisphere. I traveled 20,000 kilometers to Ecuador to see for myself if the Coriolis effect is really true or is it just a myth. Ecuador lies on the equator. That's how it got its name. Ecuador means equator in Spanish. Just an hour drive from Quito lies the middle of the Earth. Scientists once believed this is the spot that marks the equator, the line that divides the Earth into the northern and southern hemispheres. I'm standing in the northern hemisphere. Now I'm in the south. And now I'm in the middle, the equatorial line. I climb up the monument to get a panoramic view of the mountainous landscape. I reached the top. It's not that high, it's 30 meters tall. And it's extremely windy. Up in the mountains is another landmark that my guide mentioned something about a reference point to the equator. If you know the exact purpose of this landmark, do share with me in the comments below. Standing on this monument, there is no special feeling of the Zen moment or any concentration of cosmic energy. Maybe it is because this is not the real equatorial line. With modern GPS technology, it was found that the actual equator lies about 240 meters north of this monument. And that is where I will go next. I'm at the middle of the Earth. Finally, I have the chance to come here and see for myself some science experiments. Here, you get to try a few experiments, and the guide will try to convince you that the results are all because we are standing at the equator. I check my phone GPS and realize it doesn't quite show 0 degrees latitude. My guide explained that the phone GPS is not exactly accurate.
Here we use an application that we can change all of the satellites in the space. Look, for example,
Right.
here I have the commercial satellite that shows 003 or sometimes 004 like in your phone.
Right.
But look, if I change the satellite, here I have the list is all of the satellites, and the satellite that works with the military GPS, ED50. Look what happened when I changed to the ED50.
Is it a US satellite?
No, it's a Europe satellite.
Euro satellite?
Yeah, European satellite.
What's the name of this app?
The satellite is
The name of... Okay,
Oh,
the
that
satellite
satellite?
is...
this satellite is European Datum
Okay.
1950.
The name of this app?
The name of this app is GPS test.
Which one?
GPS test. Maybe in iOS is another one, but it's very similar. GPS test.
Okay. So it's exactly 0.
Look right there. You can see the huge sphere.
Yes, yes.
So to middle of the walls in Ecuador, and the reason is the huge monument was the first middle of the world founded in 1736, thanks to the French geodesic mission. Okay, with that technology, with less technology.
Right.
And look, right here we have a Marshall line measured something like in 2000s with
Right.
a military GPS. So that is the reason we have two middle of the worlds, but this is the real middle of the world. All this effect.
Right, Coriolis Effect. Yes.
Have you ever heard about that?
Yes, of course.
So
I
maybe-
come here for this.
Perfect, perfect. Okay, so look. Always the planet rotates in this direction. West to east.
West to east, right?
Perfect. So in the rotation we have different velocities because the planet is not totally spherical.
Right.
Okay, so look. In the middle, we have the largest velocity. It's something like 1,600 kilometers per hour.
Right.
Only in the middle. Now, in the poles, we have less circumference,
Correct.
so less velocity.
Right.
In the poles, we have something like 0.8 kilometers per hour.
Right.
And when the planet rotates, the centrifugal forces grow in the middle, forces that move huge masses of water or wind. Okay? So these forces grow in the middle and go to the poles like this. Remember,
Right.
in the poles we have less velocity, so these forces invert to the middle again, and for the rotation, these forces make these movements, circular movements.
Right.
And here we have the origin of tornadoes, hurricanes, cyclones, or typhoons.
So this is the north. What direction would that be?
Let's prove.
Okay.
Stand up right here
Right.
and concentrate on North America.
Right.
Okay. 1, 2, and 3. Which is the direction? Goes to the right or left?
To the left.
To the left. So it's counterclockwise.
Oh, okay.
Now, stand up on the south. Concentrate in Australia.
Right.
1, 2, and 3. Which is the direction of Australia?
Clockwise.
Clockwise. To the right.
Okay.
So counterclockwise in the north, clockwise in the south.
Okay.
Now, what happened in the middle? Stand up on the line.
Nothing.
Perfect. On the equator line, it's just straight.
Right.
Okay.
Okay.
So based on these three perspectives, we have different natural phenomena. Look, in the southern hemisphere, for example, close to Australia, we have cyclones. The direction of the cyclones is clockwise to the right. But now, what kind of natural phenomena United States do you hear in the United States?
Similar to cyclone.
Okay.
I don't know.
You don't remember the names?
Tornado.
Tornado, perfect.
Oh, okay.
And hurricanes.
Hurricanes. Yes.
So
hurricanes.
the direction of tornadoes and hurricanes is counterclockwise to the left, not like the cyclones, clockwise to the right. Now what happened in the middle? Nothing.
No.
In Ecuador, we never have these natural phenomena like tornadoes, hurricanes, cyclones, because all of the centrifugal forces, when arrive in the middle, annulate and disappear. So that is the reason in Ecuador, nothing never happens.
Okay.
Okay?
So clockwise here, anti-clockwise here.
Sure.
Okay.
And nothing in the middle.
All right. You
All
want
of
to
the
show?
theory, let's continue with the practice. If we understand,
Yeah.
in the middle we don't have these centrifugal
Yeah.
forces. So what happens if I open this? Which is the
Go
direction of the
down.
water?
Go straight down.
Straight down, right?
Yeah.
Perfect. Let me take the leaves. The leaves helps to understand which is the direction.
Yep. Sure.
So please everyone, for this activity you have 25
Ready?
seconds
Yep.
to make it, okay?
1, 2, and 3.
Yes, okay? Quick, and second leg master.
Did you see it?
Yep.
Which is the direction?
Straight down. Right.
Now, based on the theory, if we move to
Right.
the southern hemisphere, do you remember which is
Clockwise.
the direction? Muy bien. Let's go.
Please, 25. You are a headmaster. First diploma. Second one, please. Someone else is going to try.
Very good. Clockwise, right? 1, 2, and 3. Did you see it?
Yep. Yes.
Clockwise to the right.
Sure.
Let's go to the north.
Okay.
Obviously the opposite way in the north.
Right. Anti-clockwise.
Counterclockwise.
Excellent try, sir. Excellent. Someone else is going to try the activity. Raise your hand, please. 1, 2, 3, 4. Someone says 4. 5.
Counterclockwise, right?
Yeah.
To the left. Ready?
Yep.
1, 2, and 3. Do you like it? So
I
that's my
can't
science
try.
project. Now, no, I'm so sorry.
I cannot try.
No, I'm so sorry.
Okay.
My guide refused to let me try. That's because I've guessed that there was a trick involved in this demonstration. The reason the water goes down straight at the start was because it was already resting in the basin for a while. When we move to the south of the line, notice how he pours the water. He aims it at the side of the basin such that the water acquires a momentum that causes the clockwise flow. On the other side of the line, he directed the flow such that the water would turn anti-clockwise. Off camera, he shared that actually the Coriolis effect is just not sufficient enough to cause the flow of water down the drain in any particular direction. Most likely the rotation is caused by other structural build of the basin or bathtub. Next, I tried the walk in a straight line experiment.
Arms,
Right.
raise your chin, and close your eyes.
Oh, okay.
And walk like this, heel to toe, heel to toe, heel to toe. Okay? Raise your chin and close your eyes.
I can't even balance. Move your body to the north or to the south. Balance of your arms are also going to make very difficult, my friends. And for this activity,
Okay, you are doing very well.
more
You are still on the line.
You need to close your eyes, okay?
That's not fair.
Very good, very good.
Because on the line, or if I walk here, I will also be very difficult, right?
Actually, it's more because you have your eyes closed.
Yeah.
But well, here the point is try to understand better that the centrifugal forces when arriving in the middle
Right.
disappear in our legs, so maybe we feel that forces and pulling or pushing in each other. But
Okay.
again, it's a simple educational form to
Understand.
understand better.
So even if I don't do on the line, I will also have difficulty
Yeah.
with my understanding. It is a myth that it is easier to balance an egg on the equatorial line due to the absence of the Coriolis effect.
4 fingers.
Right.
Rest your wrist on the stone
Okay.
and just try tiny movements on the base.
Right.
Tiny movements on the base like this, not like this.
Okay.
Okay? So tiny movements. Look.
Nice.
Concentration, tiny movements,
Okay.
and you got it.
Okay. Hold like that.
Yes?
Alright.
Your wrist under stone. Oh my god, but you did it in something like 5 seconds.
Although I know that it is just a gimmick for the tourist, I am still proud of my achievement of balancing an egg on a nail. I have fun at the middle of the Earth attraction. The Coriolis effect may not be responsible in causing your bathwater to spin in a certain direction, but it is the real reason why cyclones turn in different directions in the south as compared to the north. In my next video, I will bring you along to the cloud forest of Ecuador and share those magical moments with you.